everybody, welcome to Quantitative Lit. This is your first day of notes for the year. A lot of this is going to be background information just to refresh your memory. So in this unit, we're going to be using percents a lot, and we need to remember how to manipulate between fractions, decimals, percentages, and how to use them in this particular section, how to use them in some pretty basic life scenarios that we might encounter. So I'm going to give you a couple tricks of the trade and some things to kind of remind you what to do when you're converting between decimals, percents, and fractions. So let's start with something you learned in probably middle school, which is how to convert from percentages to fractions and decimals, or to go in reverse from decimals and fractions to percentages. So the first situation we're going to look at right here is going from a percent to a fraction. So just something to remind you about, if you're looking at a percent actually means out of 100. So what I can do is take this 70 and put it out of 100. And then I can simplify that fraction by dividing both numerator and denominator by 10. I'm going to end up with 7 over 10. So there is my percent represented as a fraction. If I want to represent that same percent as a decimal, I just have to remember that 7 out of 10 is the same as 7 divided by 10. And I can go ahead and plug that in my calculator and get 0.7 as a decimal. Just remember that fractions are division problems. If you want it to look like the 70, you can put the extra 0 there, but you don't necessarily need to do that. Okay, and then going in reverse, let's say I have a decimal or I have a percent and I want to convert to a decimal or a fraction I want to convert to a percent. So if I'm looking at this first one here, I want to go ahead and multiply it by 100 so that I can convert it to a percentage. 33%. Same thing here. I can remember this is the same. I can convert this very easily to a decimal by doing 3 divided by 10. So it's the same as 0.3 and then just multiplying it by 100. This is 30%. Okay, so if I'm looking at this table here, this is just asking me to fill in the missing information in each row. So it's one situation I'm given a fraction, one situation I'm given a decimal, and then in the last situation I'm given a percent. So let's start with that fraction. We do have to remember that a fraction is the same. We can basically convert it to a percent quite easily by making it go out of 100 here. So if I'm looking here, if this is I can multiply by 5 by 20 to get to 100. If I do 1 times 20, that is 20 out of 10. Another way or 20 out of 100. Another way you can approach this too, just to think about, is you can just do 1 divided by 5 like we had talked about. That will help you get the decimal, which you can then multiply by 100% to get the percent. So just to repeat, there's actually a couple ways to go to the other two pieces of information. One is to write it out of 100 and then know that's 20% then, or another is to divide it, get the decimal first, and then multiply by 100. It's really your choice. If I look at this example, I can multiply it by 100%, and that's going to go ahead and give me my 45% here. And then I can go ahead and say, oh, that's the same as 45 out of 100, which I could reduce to 9 over 20. Okay. And then last but not least, if I'm going from a percent back down to a decimal or fraction, I would want to divide by 100. So this would give me 0.42, which I could then write as a fraction as well as 42 out of 100 and reduce it down to 21 over 50. So this is just an example of converting amongst those three. Just as you're going through percentage problems, you don't always want to give your answer as a decimal or a fraction. You're going to be asked sometimes to give your answer as a percentage, and we want to make sure you can go between those seamlessly. And I'm pretty confident most of you know how to do that already. And if not, you just need a little refreshed memory. So the next few examples, what we're going to do is we're going to look at percentages that you might encounter maybe by watching the news or by going shopping and trying to comparison shop and things like that. So the first example here is talking about a flat screen TV that was dropped in price by 23%. And then the new price is $412. And it wants to know what was the original price. And this is good to know when you're shopping, know if you're like getting a good deal on something or if someone's trying to pull one over on you. So if I look here, I'm going to use something to help us in these next few problems. It's a little bit of a trick when you're dealing with percentage problems. we're going to say part over whole equals percent over 100. And how this is going to help us is in each example that you'll see here, you're going to fill in two of these, two of the three that I've highlighted in yellow, and then one of them is going to be missing, and that's what you're going to solve for. So when you set up each of these problems, you're trying to figure out which two of those yellow highlighted pieces of information do you know, and which one don't you know. This one is a little bit tricky, and sometimes this class can be like this, where you really have to think about what it's saying. You don't want to just dump numbers into the problem. I admit the first time I made the answer key for this, I actually messed this one up too. So let's just make sure we're paying attention to what it says. So first of all, the 50-inch TV thing, it's great to know the size as far as like what you want in your house, but it's not something we're going to use in the problem. So what we want to look at is we don't need this number. So some of you guys are just tempted in math sometimes to just dump numbers in because you're just trained to do that and they're not always going in or they're not always in the right place. So just be careful. Okay, so what we want to know is what the original price was. So that is what was the total or the whole price before the sale happened. Okay, so what it's giving us is part of the price, what it now is when it's on sale. Okay, so we don't know the whole price, we know the part price. And then we also know the percent. This is where I actually messed up because I wasn't paying attention. If it's gone down 23%, well, that means that it is now 77% of what it used to be, because 100% minus the part that was taken off means it's now 77% of what it used to be. So in fact, I actually used 23 the first time around and I was like, what? And I actually knew the answer was wrong because I was like, that number's way too high. So just be careful with some of them with the wording. You don't always just dump the number in. So let's take a look at, I don't know the number for the whole. So that's the one we're going to use as a variable. So we know that the part of the price was $412. We don't know what the original price was. We know the percent we're going to use is 77, and then we always have that 100 there. So this is called a proportion. It's when you have fractions that are equal to one another. So when you solve a proportion, you probably remember doing this in the past. You're going to cross multiply. Okay. So when I look here, I'm going to cross multiply and get 77x, I almost did the 23 again, equals 41,200. And that's from multiplying 100 times 412. And then we're going to go ahead and divide both sides. We're just solving for x. And you're going to end up with x equals, and you're going to go ahead and get $535.06. This is the original price. So it used to be that amount, and then it went down 23% to $412. So you can see there's a decent amount of savings on that TV, and you might want to buy it just because, well, A, you want a TV, and B, because it's a decent drop in price. Okay. We've all been watching the news, and we know that Major League Baseball is in session, and then at the time we wrote these notes, there were 112 Major League players that were opting out of the season, possibly for safety reasons or whatnot. So that represents 1.6% of all Major League Baseball players who opted to sit out. How many Major League Baseball players are there? So we want to know what are the total number. We don't know how many total number of MLB players there are. We do know that part of them are the 12, and we know that this is the percent, right? So what we're looking for, and we write our part over whole equals percent over 100. We currently don't know the total again. So in this situation, we still don't know the total. Okay, so what we're going to do is cross multiply using the information that we have. So I have a 12 as part. I don't know the total or the whole. I know 1.6 is the percent, and then I go ahead and throw my 100 in there. You're going to cross multiply, so 1.6x equals 200, and then divide both sides by 1.6 using your algebra, and you would end up with approximately 750 total players in the MLB. So those two problems were very similar in the process and as far as what information was given. All right, here's another one. Recently, there were 3,102 people surveyed about the existence of Area 41, and 865 of those surveyed believe that Area 51 exists. What is this amount expressed as a percentage? So, part over whole or part over total, you might see it either way, so I'm writing it both ways, equals percent over 100. So in this situation, this is how many total people were surveyed. So we have this number. We have the part that believe that Area 51 exists. We just don't know the percent. So we're going to go through here and we're going to fill in our numbers. So we know that part of the people is 865. The total is 3,102 people surveyed. The percentage we don't know, and we know it's over 100. So cross multiplying this will end up getting us equals. So what we have is 3,102x equals 86,500. Go ahead and use your algebra and divide that over. Cross it out. And we will ultimately end up with 27.89% of people. Okay, so that's the percentage of people who believe Area 1 exists. Area 51 exists. I don't know what Area 1 is. Okay, last but not least. So our last problem here says that a recent poll of residents 18 or older in DuPage County finds that 73% of the 3,248 people surveyed are registered voters. How many surveyed are registered voters? So clearly here when we're looking at our part over total equals percent. And notice when I'm putting the percent number in these problems, by the way, we're not writing it as a decimal, we're writing it as actual percentage. We're not changing this to 0.73. We're keeping it as 73. Okay, so we're looking here. The 18, remember, is not a number. You're not using that number as far as a number that you'll plop into that proportion. It's just telling you that these are the group of people that are being surveyed. So let's go ahead and look at the other numbers that we do have. We have the percentage, this number right here. This is how many people were surveyed. We need to know what part or how many people are registered to vote out of the total numbers surveyed. So we're going to go ahead and plug in the numbers we know. We don't know the part. We don't know how many people are registered to vote. We do know that 3,248 people were surveyed. We do know that 73% of them are registered to vote. And we go ahead and cross multiply. And move our 100 over. And we have approximately 2,371 people registered to vote. I hope that number goes up because we all should be registering to vote. It's an important civic duty. But anyway, I digress. This is the end of these notes. So if you have any questions, feel free to let your teacher know and we would be happy to help you out.